My computer projects aren't going so hot right now, but that's fine. I'll just explain the problems I've got, and maybe that'll help me fix them. First, Slither.io. I like this game. While I've got a robot training in PyBullet or OpenAI, I can train myself to get longer in Slither.io. But lately, I've been training my computer to play Slither.io on its own, and this is very inconvenient for me. Slither.io isn't in PyBullet or OpenAI. It's an online game in browser. To play it, my robot has to use my mouse, which means I don't get to use the mouse. I have to play Slither.io on my phone, like some sort of caveman. And it can only play Slither.io in real time. OpenAI could play Pong at hyperspeed on my GPU. To let my robot play with humans online, the game is limited by humanity. Ugh. But I made a neural network anyway. It has two inputs. One is a screenshot, scaled down. The other is the minimap. It's part of the screenshot too, but you can't really read it in that squeezed input. That much is easy enough. But the neural network has two outputs. One true or false, whether it's clicking or not, to poop and move faster, that's fine. And a mean and standard deviation describing where its cursor will be to pick the angle of its velocity. This one is bothering me. How should a neural network output an angle? The predator I made last time doesn't really pick an angle. It picks how much it will adjust its velocity's angle left or right. I think this makes sense because the spheres are perceiving the world from a first-person perspective. But a robot playing Slither.io sees the game from above, just like the rest of us. So I think it should pick its velocity's angle, not change the angle. This raises a problem the predator didn't seem to have. The predator uses tan-H activation to describe its adjustment in angle between 1 and -1. If it's positive, the predator turns right. If it's negative, the predator turns left. And because tan-H is bounded between 1 and -1, you can't turn so hard left that you're actually turning right, or vice versa. How should I choose an angle in Slither.io? Tan-H activation seems wrong because high and low outputs would be clicking in the same area every time. It's like talking about colors in terms of hue instead of red, green, and blue. Two identical shades of red are on opposite sides of the hue scale. I don't know if this is a good solution, but it seems to be working okay. I just didn't include an activation layer here at all. I take the linear output mod 360 degrees. This still makes very similar angles look like opposites, like 1 degree and 359 degrees, but the distribution is uniform. Anyway, I trained a robot to play Slither.io for about a whole day. Let's check it out. This plot shows where the robot put the mouse each time step. Blue if not clicking, green if clicking. The lighter dots show the average the robot output, plus or minus 1 or 2 of the standard deviations it output as well. Okay. It's generally moving in one direction the whole time, but it does occasionally know it's gotta pick a different direction. But here's another problem. At the end of the map, if you hit the wall, you die. The robot's solution to that is pooping to move faster. Pooping shrinks your length. That means the robot is punished with negative rewards, but getting a negative reward now prevents the robot from getting more negative rewards when it hits the wall and dies. I've got to think more about the reward system and how it gets discounted over time. So Slither.io is probably 2 steps too complicated for me right now, which is fine, it's fine. I tend to start way too complicated so I can retreat to something simpler with some confidence. Let's see my latest problems with my predator-prey simulator. Last time, I implemented the actor-critic method to make this red sphere make continuous decisions. Now I'm implementing the actor-critic method on 2 spheres at once. The red predator wants to get close to the blue prey, and the blue prey doesn't want the red predator getting close. Eventually, I want them to chase and run away from each other in a large, colorful map. I think the way the spheres interact could be like an adversarial network, making predictions of each other's actions when they're not visible, which could lead to deception, making a cool point about consciousness. But I don't want the spheres to play on such a cool map until I get them working in a simple space like this one, and it's not working great. One problem? I'm making it too complicated again. Last time, I gave the red predator a 90-degree vision, which pointed in the same direction as its velocity. It's looking toward where it's going. Now I'm giving the red pred and blue prey 2 angles to worry about: the direction of their velocity and the direction they're looking. I'd like to see the blue guy running from the red guy while looking at the red guy behind him. He's got to be able to look in the opposite direction than he's running. But maybe this is more complicated than I need to be right now. The other problem is my rewarding. The red pred gets a point if it gets close enough to the blue prey, and that point is discounted, sort of spread across prior rewards, so there's a concept of thinking ahead. If the red pred doesn't get close enough to the blue prey, the red pred gets a -1 point reward, a punishment. This is how I got the red pred working last time, and it seems to work fine again. But I'm giving the blue prey the opposite rewards, and I'm not sure that's the way to do it. The blue prey seems to get stuck in circles. That's sort of okay, because if it runs around, it'll probably hit the red guy. Staying in one spot means the red guy has to find him. But I'd like for it to eventually learn to run away from the red guy. And to learn that, the red guy has to be good at chasing him. Getting helpful data for the prey requires the predator to be consistently good. But I'm glad to have problems which are so convoluted. When I stop for lunch, I can just face a simple problem in comparison, like what kind of sandwich I want. I'll still be thinking about convoluted problems while I eat that sandwich, of course. It's all I do here at Thinkster. Let's watch the predator and prey train up for a while. This is the 2 of them from above. This is the predator's view. This is the prey's view. And these plots show the changes they're making in their angles. Black being velocity angle, and red being vision angle. I'm hoping to go to Japan early in August, and I'm prepared for it. But I don't think it's really gonna happen. International travel is pretty hard right now. I might be attending my first lessons at the Okinawa Institute of Science and Technology on Zoom, 5 p.m. in Japan, 1 a.m. Pacific. But that's fine, that's fine. Bye-bye. By the way, I've got a Patreon at patreon.com/thinkster. I want to thank all these squidlings and elder squids. Thanks.